We had a really great talk. Nick is here for that. It's I think yours was one of the very first talks that I said, would you be interested in doing this? And then you said, how about this one better? And it was. So Nick is one of the people that is, our track is so lucky to get, because he has insight into various different aspects of space around the world that nobody else that I have contact with does. So Nick, again, thank you very much. And everybody, let's enjoy.
Okay, so 30 seconds or less on me. I've had a 34-year career in the government, most of that in the Defense Department, decades of that working space. Did 7 years in what we call the National Security Space Office, which was a joint intelligence community DoD office that did generation after next national security space architectures, right? So the technology that was 15, 25 years out, we were seeding and developing to do a next generation of a national security space architect. So I've done that for a lot of my career. Okay, much better, huh? All right, so long story made short, I have a very long history, even now, consulting the DNI on space issues. So I have had that throughout a good part of my career. I retired in 2017, went to work as a full-time professor at Penn State, bringing emerging threats and disruptive technology, including space, into the course curriculum. And then I also, leads to today, was asked to join as a senior fellow at the Atlantic Council, what they call senior non-resident fellow. And I did, and 20 minutes after I joined, they said, look, we really would like you to do something on space. And okay, I should have seen that coming. So I did. I spent about 6 months in pretty grueling research doing on small satellites and the future of small satellites, the market case for small satellites, the national security case for small satellites. And that was actually reviewed by about 35 people, believe it or not. So they have quite an extensive, went from former Secretary of the Air Force on down in, as readers for that work. So it got a lot of painful scrutiny. And I like the product came out. What you're going to see today is based on that briefing, briefing on that work. And I just completed that a couple of months ago. So that briefing really addressed, it had the first component of addressing the market case and why small satellites are growing. And I will tell you that I did similar work like this for the US government about 4 years ago, and 4 or 5 years ago, let's say, and they didn't believe me. Well, I'm not saying they didn't believe me, but there were a lot of naysayers in the group that says, we've heard that space is going to grow. We had this through the 90s. We had, the sky was going to be dark with satellites and things, but never came to being. And I thought, and I'll go into, well, the market forces driving it are different this time. You don't have the space community cheering that small satellites are going to go. I mean, you do now, but there's a, at that time 5 years ago, there's a baseline of market forces, demographic issues, technology issues that are flipping the paradigm, that have flipped the paradigm. So for those of you who are really into space and cooler than the regular science track, I'll just say that, you got to kind of look broadly and see this paradigm flip that's going on that is now coming to be in space and why it is driving the future. And so we'll look at actually what we're calling small satellites, the base case for what they can do and cost, why this is important, and what are the implications of this small satellite revolution, we'll call it, for national security, for economics, and for global security as well. And I mean, we'll look at a couple of cases just out of the Ukraine, and you can see the implications for national security are extraordinary. So what we're talking about when we say small sats are generally those that are, that are CubeSats on up, so to a couple of meters. And let's put that in the categories because that's what your commercial developers basically are looking at, or rather building when we talk to small sats. They currently, remote sensing, we see imaging, radar, LiDAR, and obviously communications. Communications being a fundamental, in LEO, being a fundamental growth driver for small satellite regimes. They're inexpensive to build and launch. They're smaller, more capable than what they were over the course of 20 years, not more capable than larger satellites. Oh, I thought that was me. They're lower cost, and because they're lower cost, and because you can do more in a smaller package, it flips the business case for using them, right? So 20 years ago, you didn't have this business case. And I'll tell you, I led in the National Security Space Office 36 agencies to conduct 2 different studies over the course of a couple of years. One study was on space situational awareness, and the other one was mission assurance, space protection for mission assurance. And in those 2 studies, which were, as I said, dozens of agencies and organizations involved, we came out with recommendations on small satellites. Now, this is 2007, okay, over a decade ago. And, you know, and we went briefed up to the 4-star level, the 3-star level, and everyone said, yeah, shook their head. Nothing happened. Nothing happened in the small satellite realm. The US government wasn't moved to developing things in small satellites. And because the contractors weren't, you know, driving forth. And so it didn't benefit Lockheed Martin or Northrop or Boeing or any of the large, and I'm sorry if everyone works there, but you look at it as a business case, it didn't benefit anyone to develop small satellites because they were getting $1.5 billion for developing big satellites. And they had a huge workforce investing in big satellites. So since that time, over 2 decades, it actually has been the universities and the small startup companies that have been pushing for the development. And, you know, some cases, NASA Ames came on board under Pete Borden, and a couple of others pushed for small satellite development, did experimentations and pushed for the small sat. But the US government as a whole did not advocate it or support it. They didn't have the vision to see this coming. Others did. The dreamers did and the universities did. So with that, let's talk about the vision for a second. The vision now, with the capabilities that have been achieved in small satellites, is to expand internet to low Earth orbit. And you need to think about that and the implications for that. I mean, you're taking the internet that's terrestrial based and you're expanding that out to low Earth orbit, right? Not an occasional ping here and there in communications. The web itself and all the comms that go with it gets lifted up and put out globally, which has a phenomenally different effect on the planet when you do that. That's the vision that Elon Musk and others are looking at. It means a free flow of information across the planet, you know, unlike what we've had before. And when you start looking at things like the Starlink terminals and such, you see why that's extraordinarily important. Because now we have the ability to collect, your household has the ability wherever it is. And part of the limitation in the internet in people is that remote living, right? If you just take your mind out of the US, or even if you go in the United States, go through the Rust Belt in the Southwest, things like that, we'll go to Wyoming, where there's something like 1.2 people per square mile, right? So the living is more remote, and that's far worse if you go to other areas in the planet, right? Africa, Southeast Asia, South Asia, you know, Latin America. Remote societies all over the planet. It's dominated by this remoteness. So there are 2 things that change the future of that. Number 1 is power. Or people, actually 3. Number 1 is power, if people are independently able to get power, hence solar cells, things like that. Number 2 is manufacturing. If you have 3D manufacturing in those environments, and I don't have to go 63 miles to the next town to buy a rake. And number 3 is communications. So you can have education that spreads globally. You can have medical technologies and, you know, all those types of things that spread globally. Okay? So that's what we're looking at. This is 1/3 of those 3 critical areas to engage the entire planet. Okay, so not only do we have that, but then we have unique sensors. If you haven't already noticed, with sensors in your clothes that are clipped out when you walk out of the store, and sensors that are being embedded in clothes and embedded in cars and every aspect of society, sensors have been miniaturized. So they're ubiquitous, and they will become more and more ubiquitous throughout society. They're ubiquitous in the phones that you carry. And you can do extraordinary things with them. In Japan, just by people's reactions when they're carrying their phones in their pockets and such, you can tell when an earthquake, you can watch the pattern of an earthquake move across Japan. Because people go, they move, they tense up a bit when the earthquake hits, and the phone registers that. And so you can watch an earthquake from a sensor and go across with the population across Japan. The Brits do things like when they're looking at riots and things, and they could tell when people look, and immediately the cameras in the streets will take a look. Oh, everyone's looking that direction, and they'll direct police towards a different direction, different area. So what I mean is just at this point, those sensors, which are ubiquitous, which are now going to be integrated using artificial intelligence and big data pools, all through small satellites. Small satellites are giving us that capability. So there's an extraordinary future for humanity based on these. They're integrating space and Earth-based sensors. I just said that through artificial intelligence. I didn't even look at that, right? I'm just thinking about that line. But that's actually the way to think about this. Think your Internet of Things on steroids being promulgated, being supported, the backbone being small satellite networks. There was a experiment that just went up with a Space Development, not Space Development Agency, I shouldn't give them credit, with DARPA called the Mandrake 2, I think it was. A couple of satellites that went up to do laser comm. This entire game is all based on laser communications. And even Elon Musk, for the first generation of his Starlink small satellites, punted on doing laser comm because it's really difficult. Because those satellites are moving in orbits, and there's perturbations due to because they're low, due to different particles that they're running into, gas particles and such, and that laser comm has to be perfect to communicate between those satellite networks. And it's critical because the amount of data that needs to be sent through laser comms. You can't just do this through radio comms, working between satellites. They're starting there, but that Mandrake experiment actually did it successfully. So they have a good point to start working from now. Over the next 10 years, this whole thing falls down if they don't have laser comms in place. But when they do have laser comms in place, it seems like they will, it will be, as I say, allow you to move data from one satellite to another across the globe, all around in literally at the speed of light. And not only that, but volumes of data, which is far more than the radio capability. Okay. So let's talk about the impact of technology on small satellites, how they came into being and why from a technology perspective. Commercial innovation in space launch was one of three significant factors driving small satellite revolution, okay? The other being, they used to say that 1/3 of the Earth is covered with land, the other 2/3 are covered with launch studies. So. But there have been advances. Again, Musk and others have done tremendous advances to bring down the cost of space launch. So when the cost is lower and you have your satellites lower, hence the second point, miniaturization technology and increasing processing power on the satellite as well as terrestrially, add these three factors together and you bring things down to an order of magnitude less. Right? So now instead of putting one big satellite on a rocket, you're going to put 48 small satellites on a rocket, and that's a huge deal. So that brings the cost per kilo. It actually has about 90%, and the future is open on that. It's going to look to bring it down significantly more. So the economics, the cost dynamics of this whole adventure are changing and opening up more business cases because it's less expensive. All right, other factors, the impact of technology, mass production of satellites. I'm sure everyone knows if you ever had exposure to the space industry, those satellites used to be built one by one, meticulous with engineers, often different from each other, so always different from each other. And they tried standardizing buses, the basic satellite, for decades. It was lukewarm in the response, but now we've really moved and are moving closer and closer to the mass production of satellites. The miniaturization technology, which will continue to reduce the satellite cost, processing power going up, Earth processing power, ultimately quantum coming online in the next couple of decades, which will increase processing power extraordinarily, and time to market. Time to market is one of the biggest aspects of this. We did generation after next planning, and our planning was 20 years in the future, and building technology roadmaps to say, hey, in 5 years we have to invest $1 billion in 1, 2, 3, otherwise we're not going to make it 20 years from now. That was the planning that we put into place decades ago. Guess what? Satellites are being updated now every 24 months in the small sat regime because new technology is coming online, and now it's affordable. You know what? You test the heck out of it. If it doesn't work, it doesn't work. You know, you've lost a couple of satellites, which are very inexpensive to put up. So there's a whole different testing regime. You can increase your capabilities every 18 to 24 months. A luxury the space industry, whether you're in science, commercial, or defense, never had. Now we got that. And the deal is because the technology advances and you can always update capabilities. There are ground-based economic drivers for small satellites, and those are probably the biggest drivers. Autonomous vehicles. I mean, this starts, I don't know, I had a friend of a friend, we were talking in a group, and he was mentioning his friend who's a farmer. And he asked him, you know, what's it like, you know, now that you're up at 5:30 in the morning? He said, I'll tell you what, I get up at 5:30, I do. I get a cup of coffee, I go sit down in my den, and I start up the tractors and set them on to drive. And they're all GPS based. It's not like he's out in the field driving them. And you could take a look at countries that I've been to, Japan and other places where they're advocating and pushing that autonomous vehicles, even if it's not for current cars, which, you know, will be decades down the road, but ultimately will happen as well. Or if it's not for trucking, commercial trucking, which is even closer, but still not in place. But for agriculture, really in place and moving forward, as well as at drones as well, you know, doing autonomous missions. All that's based on the comms that they're getting, and they have to have that type of ubiquitous comms network through satellites, because you don't have it out in the field in Kansas. So we've covered the autonomous vehicles, precision agriculture as a part of that, global internet penetration and the Internet of Things. If we say, I don't know, maybe there are a billion actuators, as they call them, on internet now. If you haven't, my washing machine just came, and I can hook it up into internet. I don't, but I could. And the same thing you've seen for your refrigerators, your phones, your phones, of course, but your lights in your house, your appliances, all this stuff can be hooked up into internet, is being hooked up. These are called actuators, right? Anything that actually does something or senses something at the end of internet. So the estimates are something like 30 billion of devices globally will be hooked up. GE doesn't even make electric light bulbs anymore without a wireless connection inside them, right? They haven't for years. So all this stuff is being put on the internet, and I'll just tell you, not with great security in most of it. It's just a nightmare that way. But all this is being put on the internet. So 10 years from now, 20 years from now, your houses are going to run on the internet. I mean, your ability to turn appliances on and off and all those types of troubleshooting that'll happen via someone, you know, in a great distance working on your washer or something like that is all going to be on internet. So how is all that data going to move? How does that data move from a little village in the middle of Africa where their manufacturing machine has broken down into, you know, into a call center someplace, and then into places that can repair, you know, or the same thing for hospitals or something like that, right? All the machinery you see in hospitals now that is in a modern era is all hooked up to internet. So again, that's the data pull that we're talking about that goes on, that has to be handled some way. And small satellites are the way that it's taken up. You're either going to cover every inch of the planet with fiber optics, or you're going to do it through space. And small sats are the best answer for this, now that they've reached a certain technology level. The growth of the global middle class. So estimates are, within the next 10 years, we'll pretty much be the richest planet that we've been in history. Hundreds of millions more people will move into the middle class. And, you know, that's sort of dependent on where you are and what you're defining as a middle class in Asia. Most of this is in Asia and driven by China's growth. So this is where the banks and the commercial industry saw a change that the space side didn't. And they said, hey, wait a minute, when you get 500 million people entering the middle class, those people want services. They're going to want services, and that's what we're able to provide support. It's interesting how watching the different industries, I mean, this was the argument I made when I was briefing a few years ago on it, and the space people were like, what are you talking? I mean, literally sitting around the table, some of the space companies that are a little more established, not part of the Musk groups who are risk takers and such, but some of them are, established groups are like, what are you talking about? I mean, literally asking, what's a global, what's a growth in the middle class have to do with this? Some people saw it, some people didn't. And that's why you get this kind of fracturing, this different understanding of it. Sorry. The infrastructure and environmental management. Of course, that's going to be another part that plays a role on this. Let's talk about overall the commercial space sector. Space startup companies got about 1,200 investments, different types of investments between 2000 and 2020. In 2020 alone, the total investments in commercial small sat companies amounted to 7.6 billion. New investors are continuing to enter into that ecosystem. So it's not just a billionaires' playground anymore. Lots of people are investing into it. And largely because of Bank of America, Merrill Lynch, and Morgan Stanley, because they each did reports on this. And, characterize a global space market is currently about 349 billion, okay? That's been a pretty standard figure, and that includes all from launch satellites, et cetera. Morgan Stanley predicted that would triple in size by 2040. It's not that far away, right? By 2040, they said they expected about $1 trillion market in that area. Bank of America and Merrill Lynch were a little more forward-leaning, saying it would be over the next 3 years, 2.7 trillion in 3 decades. Right? You can look at little specific parts of this to see indicators in other areas. Department of Labor, for example, puts geospatial information services and working that as one of the top 12, I think it is, careers for the 21st century, right? Because they see this happening and they recognize. So you've got to start to pull pieces together to this to see the broad picture, to build the broad picture of what's happening. With the rise of the global middle class, Morgan Stanley estimated that 1.1 trillion by 2040. Their bull case, however, was 1.75 trillion. And that rests on an assumption of the internet penetration greater and greater, right? Makes sense. If you have 100% internet penetration in the planet, more space services, more people moving data, more people needing data. So if at some point that gets to 100%, we're looking at 1.7 trillion in a space market. The bear case was 600 billion, which is still almost double of what it is now. And that assumes a lot of them are going to fail. You have to also assume that some of these startups and things looking to do small satellites are going to fail. They are. Nature of that business. Or they're going to consolidate into a couple. But that's the business building itself, over the course of the next decade or two. The global demographic changes that I mentioned, global middle class expected to reach 5.3 billion people, additional 2 billion people from what it is now, most of that growth in Asia. So by 2030, India and China together will represent 66% of the global middle class population and 59% of the middle class consumption. So a lot of interest in supporting that developing economic base and providing to that economic base. I will say China is way behind on this. This would have been something you thought they would have leapt on, but they actually hadn't up until recently. The services that are going to feed that global middle class are consumer television, broadband, mobile satellite services, right? Because for a mobile population, more and more we're seeing in that. Remote sensing services, supporting ground equipment, obviously. and the back end, the satellite manufacturing, space launch services. Another really interesting aspect of this is going to be the on-orbit satellite servicing, right? Which we really haven't done. Northrop's done a couple of examples of it, and Astroscale has done it in testing. But we don't have a lot of on-orbit servicing. So now that you have the ability, because you can put something up small that can on-orbit and service another satellite, yet again, we have another change in the paradigm of how satellites are going to be done and taken and worked, right? We have, now you open up a whole nother ecosystem with saying, no, we don't have to get rid of that satellite. It's still functioning. Well, we can refuel it. And we have something in orbit that can just drift over and refuel it. Of course, there's economics at play, and ISPs and moving satellites and using fuel and things like that. But you open up an entire another economic sphere. You also open up an entire another regulatory sphere, because we don't have regulations that deal with that. We don't. And we're theoretically the best out of this, the best out of most nations. So not to mention the other 100 that the other 100 countries that have satellites up there that have no idea how to regulate any of this stuff. So a lot of work needs to be done in this realm. Let's look at satellites going to war. Starlink still provides broadband communications to the Ukraine, has resulted in information free-flowing throughout the Ukraine. Musk provided 10,000 receivers. Forgetting about what it does, Russia has attempted to jam that. They've attempted cyber attacks against that. They haven't been successful. They were successful against Intelsat, or we should just say a cyber attack was successful against Intelsat for the rest of Europe, which took down a lot of their capability for something like 6 months. But look at the reporting that we've gotten throughout the country. The reporting has been good enough to do what we call BDA, battle damage assessments, or things like here what you see is Russian freighter stealing grain from the Ukraine. And this was provided by a 1 meter long imaging satellite from Planet Labs. Amazing, right? Like totally amazing compared to, and it was near real time, right? The thing did it 90 minutes later, not even 90, 45 minutes later, was on the other side of the planet, downloaded it, and you have near real time information coming out in a conflict zone. And because you have so many of them, it becomes this entire, well, we'll go into the defensive posture. You can't really see very well unless you know what you're looking for, but if you look on the lower right-hand side, there is do I have the ability? Yeah, I could do something really cool with this laser pointer. Let's get the laser pointer. Sorry. If you look over here, you can see Hind helicopters and fixed-wing aircraft that are being lined up. You see the aircraft there? That are being lined up along a runway on the outskirts of Belarus, on the outskirts of Minsk in Belarus. So, with this, you have literally almost full-time targeting, almost near real-time targeting, changes the nature of war. And it's impossible to deny anything at this point. Here, you see a fuel depot, the Veliskov fuel depot on fire after an explosion at the facility, if you can see right here, and the smoke coming up. We have another picture of that. When the Ukrainians hit the Moskva in Russian Moscow frigate, I believe it was, and no denying that pup hit. So it's militaries tend not to like that. All militaries, including ours, tend not to like having their stuff exposed like this. But this is the nature. So not only are we seeing this change in economics, in capability that's being afforded to hundreds of millions, billions of new members of the middle class globally, and to us as well, through Internet of Things. Now you're also seeing a dynamic shift in the military. And military tactics have to change to adapt to this. So it does lead a bunch of questions, though, when you get situations like this. Do commercial satellites become legitimate targets? It really complicates planning and the ideas of national security. What are they legitimate targets now? Well, China has already come out publicly and said yes. They said Starlink is a military target. Elon Musk has been supported by DoD, and he did get $1 billion plus from DoD for launch systems. So from their perspective and just setting the horizon, saying, if you're supporting the U.S. military, you're a military target. We don't care what commercial ventures that you have. Interesting that they've taken that position so publicly. And so I'll tell you a little story about this. Here's the inside story. That they're, sorry? Which is one of the reasons we have you here. Okay, so recently, and what led to China making this statement globally, so I think I have this in another slide, we're going to flip right past it when I get there, is that they screamed and yelled to the United Nations about Starlink coming near the Chinese space station. Okay? Now, the reality of that is that we went to them and asked them for the orbital parameters of the Chinese space station. They refused. We went to them a couple of times and they basically said, we're not telling you anything. And then there was a close approach, and they screamed and yelled, and then quietly they came back to us and said, here are the parameters of the station. So, yeah, you jerkweeds. I'm so pissed. But don't tell anyone, okay? You know. Anyway, so this also shifts. Not only do we see now that difference in warfare on the ground, but we see now a difference in how you have to do space and counter space. We used to have what we call a Battlestar Galactica in orbit, right? You have one satellite doing, 1, 2, 3, 4 at a cost of $1 billion. Okay, so how do you take out now 400 satellites that are basically giving you multi-mission, but there's hundreds of them? So it drives that solution set if you're in counter space type of thing, and if you want to stop someone's capabilities. Kinetic looks like a less good option, right? You have to move towards cyber attacks, and you have to bring it out of the kinetic world, because big deal. Shoot down one, okay. Shoot down another and another and another. You know what? We got to launch next week. We'll put up 45 more. Who's going to win this game, right? So it shifts the offense to being one of more cyber one. Hence, also the offense will be more AI appropriate. You'll need more AI to conduct that, and ultimately quantum. You'll need quantum encryption, which I've advocated for a big regulatory and push spending for quantum encryption, as well as computing capabilities. So just a couple of examples of how we've had to deal with adversaries. Russian small satellites have trailed U.S. military satellites in the past. We had one incident in trailing in a coming off a small sat, coming off the parent, coming off a regular satellite, and then trailing U.S. National Reconnaissance Office satellite. In November 21, they tested a direct ascent ASAT, or DAA-SAT, striking a Russian satellite, but of course putting 1,500 pieces into orbit. So nations tend to do this, pound their chest, rattle their sabers type of thing, and saying, hey, look, we can do, ASAT missions. And the U.S. responded, which I think was a good idea, and saying, guess what? We're going to commit not to doing any ASAT missions anymore. No destructive ASATs. A lot of countries have gone on board. What that was done to do was to pressure Russia and China and others, because the whole world is accepting, okay, no one's going to do ASAT, destructive ASAT missions anymore. What about you? So, ideally that pressure pushes them into a position where they say, okay, we're not going to do it. And ASATs are one of those things that you can very, very easily determine, tell that they've happened. They have a huge postage stamp that goes with them, that goes right back to the country of origin, most times. Okay, so we've had, let's move forward. China's Shenzhen SJ-21 mission recently maneuvered to capture a defunct Chinese satellite. This is one of the problems that we see with making determinations. That SJ-21, it did something that they would say is a perfectly legitimate, good commercial mission. Hey, we just took a defunct satellite, we dragged it to a new orbit, and then we brought the SJ-21 back down again. What's wrong with that? Nothing's wrong with that. Just know in the back of your pocket that that same capability that is used for that commercial venture, or what's the term? Cleaning up, space adventure, could also be used for military purposes as well. If you can grab a satellite, you can grab your opponent's satellite just as easily. So it's just worthy of noting that they have that capability that's up on the board. They've conducted their ASAT test in 2007, was sort of horrific. Put 20,000 additional pieces of debris in orbit. That I last counted, and this was years ago, we had to move the International Space Station 9 times because of the debris from that cloud that they created. Take a look at some of Chinese writings, or authorized ones or ones that not authorized, that they yank off the web very quickly. Their latest National Defense in the New Era report talks about the importance of space in the new domain. Space is particularly important to the United States because we have a projection that goes worldwide, whether you're talking about economic projection or you're talking about political or military. U.S. is a worldwide entity, period. So for us, particularly in the military terms, or in the national security terms, I should say, not military, because there's 2 types of space there, national security space and military space. So, but in the national security space, it's important to keep that secure. It's important for U.S. interests worldwide. China's a rising space power, and this is one of the arguments I make with our potato heads. That, sorry. Some generals I've spoken to, I should say.
Did I say that out loud?
Sorry, he's retired. He doesn't have to worry about it anymore.
Yeah, I don't, but fascinating how you translate that into sign language. I'm curious. Potato head. I actually had spoken with a general officer one time, and it was a small group, and I said, I'm going to try and be honest here and not be insulting, but everything you're saying is stuff that we've already talked about. We talked about this. I mean, we made these recommendations back in 2005, 6, 7, and it's one of 400 studies the Defense Department has done on space situational awareness, right? You're studying this problem yet again. So the difference between us and China is China studies the problem and then acts. And in the 15, 16 years since all these problems have been flagged and identified, they've caught up to us in multiple areas. So my question is, for the U.S. government as a whole, what do you define as success? I mean, we keep studying everything, like crazy, and it's unfortunate, but others in the world and space have caught up to us. Think of what had been done, what the world would be like if we embraced commercial space and small satellites 15 years ago. It would have been an extraordinarily different world, really a different world, which is amazing. But anyway, China's space program, 90% of it is under the PLA, as well as the State Administration for Science and Technology and Industry for National Defense. That's the actual, so there are 2 components of it. One, their Space Force, that's another term. That's under the Central Military Commission, and the other parts of it are under the State Administration for Science and Technology Industry for National Defense. Their National Space Administration, China's, 50, 60, 70 people, something like that. Not a big place, and it has really, really very limited, just the moon at this point. Everything else, including manned space flight, is under the PLA. So, let's see. Okay, I think I mentioned this already, so I said I'd hop past it once I did. This is just to give you a little vision as we talk about adversary stuff, that China's Space Information Corridor, as they call it. This is an OV1, it's an Operations View 1. So what you're looking at is on the top layer, China's communications layer, all the communications they offer countries globally, countries within the Belt and Road Initiative, like 140, 50 countries. Countries that are in China's digital Silk Road, 60-something countries. They say, hey, you can use all these space capabilities. You can, pay us for it. It's a minimal amount, pay us for it. The same thing as our remote sensing capabilities, our PNT, our BeiDou, our remote sensing, in the future, our space-based solar power. And on the bottom level, you have China builds the ground application layer. 13 stations, for example, in Africa, they're pumping the information around locally in countries. They're pumping the information up to their satellites. So if you're in the national security world, you would say, this is brilliant. I mean, you're basically giving this stuff to people. You're democratizing space for the planet, which they are, and at the same time, you're collecting all the information and establishing information dominance over space. It's just a level of thinking that we in the U.S. don't have. Okay, so satellites, and I'll kind of wrap up here, I think, with a couple of slides. Where are we now, time-wise, Rain?
We've got about 20 minutes.
Okay, but does that leave for questions and answers? Because I want to leave a
That
fair.
would be good until
Okay, so let's just take a few more slides, and then, because I've noticed that we always run short on questions, or rather answers. So, which we might run short on answers anyway, depending if they're hard questions or not. So let's cover two things. Look, as I've said, small satellites are a disruption. What's called a disruption in this business. They're positive disruptions and they're negative disruptions. You know, to life as you know it, cell phones were a disruption, right? Everyone's looking at cell phones constantly, and it's everyone's looking at cell phone. So it is a positive disruption, though. There are negative aspects of it, and there are negative disruptions as well. So let's take a look at the positive disruptions of small satellites. Cost reduction. Well, we've certainly discussed the cost reduction and what it is. Technology refresh rate, 24 months, 18 to 24 months for new satellites. So cheaper to put up, more advanced technology moving up quicker. Resilience in the number of satellites, just to recap this, right? The more satellites you have up, the more targets you have up. And no one's taken all of them out. And anyone who does, who even thinks of that, is destroying an orbital belt for the entire planet. So unless you plan on going to war with the entire planet, probably not a good idea or in people's thought processes, right? Attacks against commercial companies, as I said, complicates the decision tree for everybody, right? What happens, particularly in pre-crisis. You know, it's one thing if you're in an actual war, you can say, hey, look, those commercial satellites are supporting the American Defense Department. You know, we're not having that. We know it's a commercial satellite, but we're taking it out. Okay, that's one possibility. Possibility number two is you require what they call exquisite intelligence. That no, we only want to take out these 4 bands because we know DoD is operating on those 40 bands or whatever it is. So we jam those specific bands. But you've really got to have, if you're a foreign country, you've got to have exquisite intelligence to know that. So it puts the burden on you to develop and to work more of that to be able to take that type of action. So, but you can't do that basically in pre-conflict times. So again, the planning cycle for all these things from a diplomatic perspective all the way through military action becomes dramatically more complex. Cost-effective and increased capability. Negative disruptions. Satellites can be undetected weapon. I mean, at a minimum, you're talking about something moving 17,500 miles an hour in low Earth orbit. I have a photo. One of the best parts of my career was I used to give lead the DoD tours, you know, for senior people for space shuttle launches. So been to 11 launches. I think 8 of them actually went up. But when you're in the environment, you're looking like in the rehab facilities, you're right under the space shuttles and such. They have pictures that I should probably incorporate that in, of windows, and they're like 1.5 inches thick. The space shuttle with a paint chip embedded halfway through that. That's the destruction of a paint chip. So imagine the destruction of a small sat, you know, moving at 17,500 miles an hour, hitting your satellite. So they can be weapons, or they can be reconnaissance platforms. You don't know what's carried on that. I mean, theoretically, you know what is on Starlink, but from other countries or other commercial providers globally, you have no idea what's on that platform. They can tell you, they're supposed to say to the UN what's on it and what the capabilities are, but they don't. No one does. So you have a threat in the sense of reconnaissance, you have a threat in the sense of something that can be used as a weapon. Space technology can be dual use, as I pointed out in the case of the Chinese Jan 21, okay? And, you know, last but not least on this, there are significant challenges to detecting, tracking, and characterizing these satellites. I mean, you know, we had about 4,000 active satellites. By 2030, 2035, something like that, we'll be up at about 40,000. And that's just the active satellites. So tracking this stuff, and particularly the small ones, the ones that don't function, thank you so much. they go out, they're almost impossible to track because they move in orbits, and after a few orbits, you don't know where they came from. You can see it and track it, but you don't know where it came from, its origin, its story, its capabilities, or anything else about it. So there's a lot of problems inherent in this when you start going into the tens of thousands of tracking of things like CubeSats and others. Space traffic management, that is the component of this that we're all going to have to deal with. And I'll just sort of summarize a couple of these things that if we have 40, 50,000 satellites, you have to be able to provide management. Same way you provide air flight management, right? The FAA does that. You've got to figure some way of providing that type of capability, not only to the United States, but globally. So up until recently, I got to tell you, we were very slow in our response on this. And I am stunned that places like China didn't just move ahead and say, you know what, the U.S. has taken years, let's just jump on this and take a lead. So just now, we seem to have picked up the pace in Department of Commerce requesting like $88 million to do this, for their office to provide. Oh, that is so annoying. I'll get them next time through. It's a huge dynamic that we're going to have to provide this space traffic management, not only for the U.S., but for the world, and to our enemies. There's a lot that goes behind this. We're obligated under treaties, the Outer Space Treaty, to be able to manage and control. As I mentioned, Article 6 does this for all countries that are signed. All countries have no policies. There are a handful that actually have policies that are able to deal with this. So all the countries that are flying satellites that are so proud of it, what happens if your satellite, leaks gas or something like that that impacts other satellites? What's the regulatory control regime you have in place? And they have none. So a lot of possibilities for big issues. We're about ready? Yeah. Okay, so I'll just give you kind of a last one that we look for. There's a lot of bodies that do international cooperation, government bodies as well as company bodies. It's not just a government thing. So there are company and industry groups that do global coordination standards. For example, consultative committees they get. So this is what's called Track 2 diplomacy, or Tier 2 diplomacy, or 1.5 diplomacy, depending what it is. So maybe the government isn't conducting negotiations on how to do satellite disposal, right? But industries across the globe will do those discussions, and then they'll each go back to their respective governments and say, hey, look, we got to get something done here, and this is what the industries of the planet think that we should move forward. So you hear that term sometimes if you read Track 2 diplomacy. That's what we're talking about. And there's a lot in the space industry. There's for not space debris coordination, there's standards of coordination, there's space safety, there's information and sharing, Space Analysis Center. There are these analysis centers advocated by Homeland Security in all spheres of security. This being one of them, where they have dozens and dozens of companies playing a role, sharing information. So it's a huge effort. What I'm saying is that coordination is a huge effort that goes from companies all the way through governments globally to figure a way forward to adapt for small satellites. The question is it being done fast enough? And the answer is no. The technology and the launch rates and stuff and the capabilities brought online are moving much faster than the regulatory environment, or even the casually agreed to environment is globally. And this is probably one of the bigger challenges that we're facing onto the future. Anyway, I have a bazillion recommendations and reports. If any of you are that interested, online you can find it. It'll numb you with all the detail on it. But
Can I get a copy?
yes, absolutely. So let me just close with that so we can leave some time for questions and answers. And happy to take any questions on it.
Anybody have any questions, please come up to the mic. It sort of turns itself off all the time. There we go. So I'm fairly certain I know the answer to this, but I am curious, officially or semi-officially. When you have any group that wants to put up a satellite, a long-term satellite, is it done with governments that they say, okay, we know what you want to build, we're asking you to put something else on there that nobody knows about?
So, you said this is being recorded, right?
Yeah.
No, so
That's it. Just we're
no, just
speculation.
between us kids. No, it leads us to the question, what they call it is unworn sensors, right? So the question is, do governments make deals with commercial providers to put additional sensors on board? And what you find is that commercial providers go around selling additional space that they have. Hey, we have additional space. You could put a widget on this that'll tell what everyone's haircuts are like, and I mean, just stuff like that. So the answer to your question is yes, that these things happen throughout the planet, and they'd be crazy not to take advantage of them. Sometimes it just doesn't make sense, and there's always a disconnect between what the commercial side thinks is wanted and what the government says. Don't tell them, but we already got this, in spades. So there's always this discussion that's happening all the time.
Thank you.
Hi. What do you see as the global response for a successful, let's say, PRC cyber attack against a commercial P-LEO constellation?
Well, so two things. First, that depends on level of attribution, if you want to talk about a global response. But yeah, it's a problem area for the U.S. because we have no stated doctrine of deterrence or response. I mean, the only thing we say on any space thing is that we will respond in a domain and the time and place of our choosing, in a domain, time, and place of our choosing, which is okay, but typically for the United States, someone pokes us and we don't do anything. And they poke us again, and we say, we're the big kids on the block. We're not going to scrapple with a bunch of, things like that. And then they poke, hey, this is great. And they poke us a third time, and we take a sledgehammer and clobber them. And they go, what the F, dude? We did it 3 other times. You didn't do anything. Yeah, and that's just our thinking. We don't respond in a way culturally, dynamically that others understand. So it's a real, I don't know is the answer to your question.
Thank you.
Hey, how you doing? What? Okay, a little closer. Can you hear me? All right. Yeah, no more toes.
Get a chair.
But I'm back old enough to remember the rise of the internet and the challenges of deployment. And I see 3 intertwined challenges that all these satellite systems, good enough, thank you. These satellite systems are going to encounter, which is basically the last mile, which is spectrum.
Right.
The other one is, I'm getting a little geeky here, IP4 and IP6 is creaky in their architectural conception. And employing it on top of a mobile, all endpoints being mobile is going to be a challenge, which leads to the third challenge, which is probably, no one's probably thought about, is that all these space-based internet backbone providers are going to have to interconnect. So this is basically, this is like the early, SNA networks versus various other early architectures.
Right. You realize that things like laser comm eliminates, a good part of that.
Right, but that means that we're going to have an architectural agreement on what is the whole infrastructure of a laser comm.
Right. So that's, if you look at the government, they'll give you that answer.
Yeah.
In fact, you can look online for things like, and I can't even speak for the whole government, but
Right.
things like a Space Development Agency. They have the architectures with Tranchen 0, 1, 2, 3, 4, all online, and what the architecture is supposed to look like, and even what the parameters of the craft and the comm systems have to be. They have a first generation,
Right,
which is
right.
radio,
Physical-
second generation.
Physical layer is,
Right.
right.
So
It's easier to work out. It's when you get to the architectural higher layers that, we're going to have.
Right. I mean, it's easier for one entity to do it than it is for the entire commercial industry to do it. We run into the same problem with standards for on-orbit servicing,
Right.
not just policy, but, okay, well, how do you grab the satellite? What hooks do you put on it to grab it? You have a bazillion different satellite providers. What's the standard? That's why things like international standards organizations, ISO.
Yeah, been participating in early that kind of
Okay,
stuff, yeah.
so, but that's why they're so important, why that track 2 discussion is so important, because they push and try and establish those standards.
And when the real world hits the road, we do something different.
Yeah, every plan goes out the window with first contact with the enemy, as we say. But you look at a generation later, and we'll work these things out.
Oh, yeah, Ultranet, I mean, stuff like that.
Yeah.
So I'm not too familiar with satellites, I'll be honest, but I was wondering if these small.
Does that mean you would come up and lie normally, or just, you'll be honest now, but
I'll
normally
be
you
honest
wouldn't
now,
be?
but I'll lie later. My job's 90% lying.
Okay, go ahead.
So my question is, do you foresee like these small satellites providing the same capability of like GOES 19 to other places such as I don't know, Africa, Europe? Because I've noticed that I don't get like any. I have no idea where to access weather satellites for those countries.
Okay. At some point after, you're going to explain how you don't really know about satellites, but you know GOES 19 by name. I find that extraordinary.
Weather.
Okay,
I
but,
do weather.
Okay, but I don't think I think there's a business case for one, but not for the other. Is there a business case for small sats doing weather? I'm not sure. I don't know. When you look at things like when satellites have to recharge and over oceans and things like that, I'm not sure why, when that's already being covered, globally, someone has to find a business case, and that's a part for commercial sats. It's money. If you're talking about the commercial small sats, will the next generation of GOES be reduced in size? I would say so. Just based on the technology advances. But so, will it ultimately get down to that small site class? I have no idea. But I don't think there's a commercial business case for doing things like that, like weather.
Okay, thank you very much, sir.
You're welcome, sir.
So my question is related to space traffic management specifically, and it's basically, what do you think the actual chances are that we get some kind of international standard that actually kind of makes everything work versus like Elon Musk keeps chucking up dozens of satellites at a time, and then a decade later China's like, well, you did it, so I'm going to start doing it, and then we have too many. And
so here's
fingers.
Here's the deal with space traffic management. If you're the only one putting the money in it and putting the standards out and saying, look, here's the data, this is how the data is going to be. If someone comes up with a better way of doing it and is willing to fund it, you might get knocked off the top of the chair. But the reality is the $88 million that Department of Commerce requested, which I think Congress is funding, and Congress has been after them for 3 years to get off their butts and to.
They have.
Oh, yeah, okay. They have? Great. Everything?
Oh, no, I mean, they've been after them.
Yeah. Oh, they have
been complaining a lot.
They have been complaining that DOC hasn't been moving forward. So, assuming that they fund that thing, okay, you can tell France or the UK or anyone else, good, then you come up with a better solution. Now, Commerce has proven their willingness to accept solutions, provider solutions from commercial providers from globally. So, depending where you are, what industry, you may think that as a threat or think it's great. So, until someone comes out, it's the car. It's Henry Ford. If you're the only one producing it, people are going to buy your car. So someone else better come out with something damn good to take over that role. And this is very much pushed out to the commercial environment, and they're very open about bringing other capabilities in as part of that space traffic management program.
I think the one other question with that is, what happens if and when the standards become uncomfortable, really? Right, like what happens when, we realize, hey, there's just too many satellites up there and we can't just keep throwing up mega constellations.
Well,
but,
there's
another country comes along and they want to do it, right?
There's tons of problems with the entire world. I mean, who are you
okay.
using, your math or somebody else's math to do this? I mean, I can't tell you how many close approaches we had. And we said, no, it's going to be this. And the Russians say, you Americans don't know your math. Okay, what's it going to be? It'll miss by miles. What did it miss by? 23 feet. Stuff like that. But they do become issues, Things like whose math are you using to do this? Whose standards and working that out. But that's something that has to be done over years.
Sure, thank you.
Sure.
Hi. So with these like enormous constellations, like with Starlink, is like Elon's talking about like 20,000 satellites, and then the Amazon one and other similar ones, you have hundreds of thousands of these things in orbit, and they all weigh about 1,000 pounds or 2,000 pounds, whatever.
No, way less than that, but go ahead.
Well, whatever. And so they, you know, what, like, has anyone looked at the implications, like, of the, of either for the atmosphere or for like, for like the scarcity of the resources, and just sort of the idea of sort of over, you know, 100 years, like throwing these things up every, you know, the Starlinks have been, right, several of them have already been lost, and they only last a year or two, I guess, at this point. And so, you know, that's like 20,000 you have to replace over every couple of years, over 100 years, and it's like, well, geez, how much sort of pollution does that create? Is it a concern? Is it like, and is it just the idea of throwing up $20 billion worth of satellites every couple of years from an economic standpoint? Like,
So, to answer your question, I don't think that you can plot this out 50 years.
Thanks.
Or 100 years, I think, because the technology is changing so dramatically as we're going through it, right? So number one, you can't take a long-term approach with this. Number two, as you pointed out, those satellites come down in a few years. Okay, so it's not like you're going to have things sitting up there forever. Why, even if you lose control of it, ultimately it's coming down in a short period of time, right? 5 to 10 years. So you have that component of it. I think as technology advances, laser comms advance, you'll probably wind up putting less with better comms capability, more processing power, more comms capability requires less number of satellites. Technology increasing requires, you know, gives us miniaturization. So a lot that's going to happen over the next 5, 10, 15 years. Most of the discussions now are maintaining the orbital regimes. And you know, I'll just give you something to take away. When you see those movies, little GIFs or something of the planet with satellites around it, and you know, oh my God, it's surrounded by satellites. Reality is space is really, really big. I mean, really big. And those satellites are really, really tiny. And even though they only fit certain orbits, it's still pretty darn big to do that. So it's an issue of concern, mostly in populating orbits, specific orbits. It's an issue of concern, and you know, I don't think people are addressing fast enough, but they are addressing it.
First, the studies that you talked about at the beginning of the banks, that'd be great to find out. Can we just get those online, just Google search, or do you have like a specific area?
You mean the study I talked about initially that this was based on?
The banks one that you mentioned early on. The one from the banks,
Yeah.
Merrill
I
Lynch.
think you can. I know you can get a synopsis of it. The answer. I think maybe you can get the whole study as well, but you can definitely get most of it, if not all of it, online.
And
Yeah,
then-
just search like Merrill Lynch space, you know, something like that.
Right, and then just on the commercial satellites, you're saying how slowly the industry is finally coming around and doing the smaller satellites with like Starlink, and then I've noticed recently in the news you got a bunch of mergers happening,
Right.
With the larger geo satellite guys trying to pick up a few low Earth orbit guys.
Mhm.
So where does that put the geo guys? Are they just trying to jump into that space now? And
They
try
have to.
fill in? Are they going to? Is geo going to essentially not become useless, but more or less be taken over by the lower?
No. They're actually, this is what you call a hybrid architecture, and they're actually bringing different capabilities to the table. So when you talk about broadband use, geo is your best asset because it can cover a third of North America in one band, right? In one boom. So you want to give a TV channel or XM radio and drive across the country, you get a geo bird to do that instead of pinging a little satellite every time it comes by. So there are different things that they offer from the remote sensing. Until capabilities get dramatically different, your low Earth orbit, the lower you get to the planet, the better capability you're going to bring. So,
Thank you so much.
welcome. Anything else? Ma'am, all yours.
Okay, one first, say thank you to everybody, and thank you, Nick.
Thank you.